Hey there, science fans. Today we're going to talk about something that sounds super complicated, but is actually incredibly cool and, honestly, surprisingly simple. We're diving into the world of geometry to unlock a secret that has been helping people for thousands of years. I'm talking about the Pythagorean Theorem. Now, don't let the name scare you. It's just a fancy way of describing a special relationship in a very special kind of triangle. This isn't just any old triangle we're talking about. It's the right-angled triangle, or as we like to call it, the right triangle. It's the superstar of shapes, and you see it everywhere, from the corner of a book to the sails on a boat. So what makes a right triangle so special? Well, it has one angle that is exactly 90 degrees. Think about the corner of a square or a perfectly upright wall meeting the floor. The two sides that form this right angle are called the legs. We can call them A and B. The third side, which is always the longest one and sits opposite the right angle, has a special name, the hypotenuse. Let's call that one C. The Pythagorean theorem is all about how these three sides, A, B, and C, are connected in a mathematical dance. Imagine you're a builder, an artist, or even a video game designer. Knowing how to work with right angles is essential. The ancient Egyptians knew this. They used ropes with knots tied at specific intervals to create perfect right angles for building their magnificent pyramids. The beauty of the Pythagorean theorem is that it works every single time for any right triangle, no matter how big or small. This consistency is what makes mathematics so powerful and reliable. All right, let's get to the heart of the matter. The magic formula. It looks like this: a squared plus b squared equals c squared. It might seem like a secret code, but let's break it down. The A and B represent the lengths of the two shorter sides of the right triangle, the legs. The C represents the length of the longest side, the hypotenuse. The little 2 next to each letter means squared. Squaring a number just means multiplying it by itself. So, a squared is just a times A, B squared is B times B, and C squared is C times C. It's that simple. Think of it like building actual squares on each side of the triangle. So, what does the formula a squared plus b squared equals c squared actually tell us? It says that if you take the length of leg A and square it, and then you take the length of leg B and square it, and you add those two results together, you will get the exact same number as when you take the length of the hypotenuse C and square it. It's a perfect balance. The area of the square built on side A plus the area of the square built on side B equals the area of the big square built on the hypotenuse C. It's a mind-blowing yet elegant piece of mathematical poetry in action. Now for a fun fact. While the theorem is named after the ancient Greek mathematician Pythagoras, who lived around 500 BC, historians have found evidence that other civilizations knew about this relationship long before him. Clay tablets from ancient Babylon, dating back to 1800 BC, show that they understood and used this principle for calculations. Pythagoras and his followers, however, were likely the first to formally prove it and integrate it into a structured system of mathematics. So, while Pythagoras gets the credit, this amazing idea is a shared piece of human ingenuity from across the ancient world. Science, it's a team sport. Theory is great, but seeing something in action is where the real fun begins. Let's take the Pythagorean theorem for a spin with a classic example. Imagine we have a right triangle. We know the length of its two legs. Let's say leg A is 3 units long. It could be 3 inches, 3 feet, 3 miles, whatever. And leg B is 4 units long. Our mission, should we choose to accept it, is to find the length of the hypotenuse, C. This is the side we don't know. Time to call in our trusty formula, a squared plus b squared equals c squared. First, let's plug in the numbers we know. We have a equals 3 and b equals 4, so our equation becomes 3 squared plus 4 squared equals c squared. Now we just have to do the math step by step. What is 3 squared? It's 3 times 3, which is 9. What is 4 squared? It's 4 times 4, which is 16. So now our equation is even simpler. 9 plus 16 equals c squared. We're getting closer. This is the part where we add the two numbers together. Let's do the addition. 9 plus 16 equals 25. Awesome. So we now know that 25 equals c squared, but hold on, we're not quite done yet. We're looking for the length of CE, not CE squared. To get C all by itself, we need to find its square root. The square root is the number that, when multiplied by itself, gives you the original number. So, we need to find the square root of 25. What number multiplied by itself gives us 25? Let's think. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. We found it. The square root of 25 is 5. That means C equals 5. So, for a right triangle with legs of 3 and 4, the hypotenuse is always 5. This famous 3-4-5 combination is known as a Pythagorean triple, and it's a super handy shortcut to remember. See? You just use the Pythagorean theorem. It's not so scary after all. It's just a few simple steps to find a missing piece of the puzzle. Okay, so we can find the side of a triangle on a worksheet. That's neat. But where does this actually show up in our daily lives? You'd be amazed. The Pythagorean theorem is a secret weapon for solving all sorts of real-world problems. Let's consider a very practical example. Imagine you're a firefighter and you need to rescue a cat stuck in a tree. The cat is 12 feet up the tree, and for safety, the base of your ladder must be placed 5 feet away from the base of the tree. The question is, how long does your ladder need to be to reach the cat? Let's picture the scene. The tree standing straight up from the ground forms one leg of a right triangle. The ground between the tree and the ladder forms the other leg. The ladder itself, leaning against the tree, forms the hypotenuse. We have our right triangle. The height of the cat in the tree is one leg, so A equals 12 feet. The distance from the tree to the base of the ladder is the other leg, so B equals 5 feet. The length of the ladder is the hypotenuse, C, which is what we need to find. Let's use our formula, a squared plus b squared equals c squared. Time to plug in our numbers. 12 squared plus 5 squared equals c squared. First, we square the numbers. 12 squared, that's 12 times 12, is 144. 5 squared, so 5 times 5 is 25. Now our equation is 144 plus 25 equals c squared. Next, we add those two numbers together. 144 plus 25 equals 169. So, 169 equals c squared. We're on the final step. To find CE, we need to find the square root of 169. If you test it out, you'll find that 13 times 13 equals 169. So, C equals 13. The ladder needs to be exactly 13 feet long to reach the stranded cat safely. Thanks to the Pythagorean theorem, the firefighter can grab the right ladder for the job, save the cat, and be a hero. This same logic applies to so many other situations. A carpenter uses it to make sure the corners of a frame are perfectly square. A baseball player can calculate the distance they need to throw the ball from second base to home plate. It's a tool for architects, engineers, navigators, and even you right now. It's everywhere. So we've journeyed from ancient Greece to a cat in a tree, all thanks to one elegant formula. The Pythagorean theorem, a squared plus b squared equals c squared, is so much more than just a dusty old rule in a math textbook. It is a fundamental principle that describes the space we live in. It's a testament to the power of human curiosity and our ability to find patterns and order in the world around us. Its simplicity is what makes it so brilliant. With just 3 variables, it unlocks a universe of problem-solving potential, connecting algebra and geometry in a beautiful, inseparable bond. The importance of this theorem stretches far beyond simple triangles. It is a foundational concept for trigonometry, which is used to calculate angles and distances. Navigation systems in your phone or car use principles derived from it to pinpoint your location. This is called GPS, the Global Positioning System. It calculates distances from satellites to your receiver, forming giant triangles in space. Without a solid understanding of these geometric relationships, modern navigation would be impossible. We'd all still be using paper maps. Think about that next time you ask for directions. From the grandest scales to the smallest, the theorem holds true. Engineers use it to design stable bridges and towering skyscrapers, ensuring that all the forces are balanced and the structures are safe. Video game developers use it constantly to calculate distances between characters and objects, making the virtual worlds they create feel realistic and interactive. Even in art and design, understanding the relationship of a 3-4-5 right triangle can help create compositions that are visually stable and pleasing to the eye. It's a universal tool for creation and measurement. In the end, learning the Pythagorean Theorem is like learning a secret handshake with the universe. It shows us that the world is not random, but is governed by elegant and predictable rules. It empowers us to look at a problem, like a ladder against a wall, and see a simple solution hidden within a shape. It's a reminder that math isn't just about numbers, it's about understanding the structure of everything. So the next time you see a right angle, give a little nod to Pythagoras and the countless thinkers who came before him. They gave us a tool that truly helps us build, navigate, and understand our world. It's science, and it's awesome.